Hey folks! Welcome back to this tutorial on Python. Let us quickly recap what we have learned till now. We have looked into the key features of Python, which make it a widely used programming language across multiple domains. We also had a look at the different data types, both atomic data types like float, string, and iterables like list, tuple, dictionary, etc. We talked about the decision-making statement, if-else, and the looping statements, for and while. We also learned about the operators, which are a vital part of programming. In this video, we'll have a look at the unique and interesting features offered by Python, which are focused on code readability and conciseness. Python is built on a set of principles, which are highlighted by the Zen of Python. The Zen of Python is a collection of guiding principles and aphorisms that serve as a philosophy for writing Python code. It was written by Tim Peters and can be accessed by typing "import this" in a Python interpreter. Here is the full Zen of Python. These principles emphasize simplicity, readability, and the idea that there should be one, and preferably only one, obvious way to do things in Python. They highlight the importance of exception handling and writing code that can be easily understood and maintained. Ternary syntax refers to a shorthand way of writing conditional expressions in programming. It is a compact form of an if-else statement, typically used to assign values or execute expressions based on a condition. Functionally, it is no different from an if-else statement, but visually, it offers better readability. In the second cell, print statements are executed conditionally using ternary syntax. In the third cell, values are assigned conditionally using ternary syntax. Unpacking refers to the process of assigning values from an iterable, like a list, tuple, or dictionary, to variables in a single, concise operation. It allows you to break down a collection into individual components and assign each to a variable. It serves as a visually cleaner alternative to obtaining the values through indexing. The first example unpacks a list of fruits. Given that we know the number of elements in the list, we can assign an appropriate number of variables to unpack. The same holds true for a tuple as well. The second example demonstrates this. Dictionary unpacking is a little bit different. We unpack in terms of keys and values. A dictionary object has a method called items, which gives out key-value pairs one by one. Circling back to the first example, we have assigned 3 variables to unpack, since we knew that there were 3 elements in the list. But what can we do if the number of elements in the list or tuple are unknown? Let us look at this example. We have a list containing the full name of a person. Let us assume that we know for sure that the first element is the first name, and the last element is the last name, and everything else in the middle are the middle names. The problem is that a person can have multiple middle names. We solve this by using a technique called extended unpacking. Note that there is an asterisk before the variable middle underscore names. The first element in the list is unpacked into first underscore name variable, the last element is unpacked into the last underscore name variable, and everything in the middle is assigned to middle underscore names as a list. If the list contains only first and last names, the middle underscore names variable will be assigned an empty list. In Python, comprehensions provide a concise way to create collections, such as lists, sets, or dictionaries, by applying an expression to each item in an iterable, like a list, tuple, or range. This can significantly improve readability and reduce the amount of code needed for common tasks. In the first example, we create a collection of squares of the first 5 natural numbers, using a list comprehension. In terms of output, it is the same as creating a collection using a loop. But a list comprehension offers some benefits, in terms of cleaner code and efficiency. The second example is of set comprehension. It is virtually the same as a list comprehension, but the end product is a set in this case. Note the braces instead of square brackets. Since the end product is a set, all duplicates are automatically removed. Even though there are duplicates in the input list, the output set does not have those. A dictionary comprehension is given in the third example. We need to give the expressions for both keys and values when doing a dictionary comprehension. We do not have tuple comprehensions since tuples are immutable. Next, let us understand what generators are. Generators are a special kind of iterable, like lists or tuples, but they generate items on the fly one at a time, rather than storing them in memory. This makes them memory efficient, especially when working with large datasets or streams of data. A generator doesn't generate all values at once. It yields each value as we iterate over it, which saves memory. We call this property as lazy evaluation. Generators are also stateful, which means they are aware of the last value that was generated, so that they can use that to generate the next value. We will build a generator function later, once we have an idea of functions. But for now, we will look at a generator comprehension. In this example, we try to calculate the sum of squares of first 100 million natural numbers, using two approaches. First is a list comprehension, and the second approach is using a generator comprehension. In a list comprehension, the entire list of squares is stored in memory. We can see that the memory allocated to squares_list is considerable, and the operation takes 13.6 seconds. But if we look at the second example, we can understand that generator comprehensions have an edge. Though the time savings is marginal, there is a huge advantage in terms of memory. The squares of numbers are calculated only at runtime, and never stored in memory. Only the generator object is stored in memory, which takes only 208 bytes. When the data is huge, generators have an edge, because they avoid the overhead of storing everything in memory. The walrus operator, introduced in Python 3.8, allows developers to assign a value to a variable within an expression. This can help improve the readability and efficiency of the code by combining assignments with other operations, especially in situations where a separate assignment statement would be required otherwise. In this example, we calculate the value of an algebraic equation for the first 10 whole numbers. We create a collection of the values, only if they are greater than 5. The first example takes 5 lines of code to achieve this. But the second example, which uses the walrus operator, achieves this in only 1 line of code. The value of the algebraic equation is calculated and immediately assigned to y, which can be checked for a value greater than 5. In Python, both lists and strings support multiplication. When you multiply a string by an integer n, the string is repeated n times. When you multiply a list by an integer n, the list is repeated n times. In the first example, the string abcd_ is repeated 5 times. The integer can be the first or second operand. But the common practice is to have the integer as the second operand. In the second example, a list is multiplied by an integer. The elements of the list are repeated. Tuple also supports multiplication, as demonstrated by the third example. These are a few interesting features offered by Python, which help in making the code efficient and cleaner. In the next video, let us have a look at functions and classes. Until next time, happy learning!